Here is something that will genuinely stop you cold the next time you walk past a cancer charity collection tin. We have been officially at war with cancer since 1971. That is the year Richard Nixon signed the National Cancer Act and declared what was essentially a formal military-style war on the disease. He predicted we would have a cure within 5 years. We are now more than 50 years into that war. We have spent over $200 billion on cancer research in the United States alone. We have produced more scientific papers on cancer than on almost any other subject in the history of medicine. And people are still dying from it at a rate of approximately 10 million per year worldwide. So what exactly is going on? The answer is considerably more complicated than most people realize and considerably more interesting than the version you usually hear. Let's start with the most important thing most people do not understand about cancer. Cancer is not one disease. This sounds simple, but the implications are genuinely enormous. And almost everything that confuses people about cancer research makes immediate sense once you actually absorb this fact. When someone says we need a cure for cancer, they are saying something roughly equivalent to saying we need a cure for infection. Infection is not one disease either, it is a category. A bacterial infection in your ear, a viral infection in your liver, and a fungal infection in your lungs are completely different problems requiring completely different solutions. Cancer is the same situation except worse. There are over 200 distinct types of cancer. Each type involves different cells in different organs behaving in different ways, driven by different genetic mutations. Leukemia and pancreatic cancer, melanoma and breast cancer have approximately as much in common with each other as a cold has in common with malaria. They share a general category. They do not share a disease. Curing cancer is not one problem. It is 200 different problems that happen to share a name. Here is something that should reframe how you think about this entirely. We actually have cured several cancers. Childhood leukemia was almost universally fatal 50 years ago. The survival rate is now over 90%. Certain types of testicular cancer that were death sentences in the 1970s are now curable in the overwhelming majority of cases. Hodgkin lymphoma, certain thyroid cancers, early-stage cervical cancer, multiple types of skin cancer can be caught early. The reason these victories do not feel like victories is partly because we called the whole category cancer and then defined success as curing all of it simultaneously, rather than acknowledging that succeeding against specific types one by one is exactly what success in this situation actually looks like. The problem is not that we have made no progress. The problem is that some of the remaining cancers on the list are almost incomprehensibly difficult problems. Let's bring up what makes cancer specifically hard to treat, compared to most other diseases. When you have a bacterial infection, your immune system and your doctor are both fighting something that is biologically foreign. The bacteria are not you. This distinction matters enormously because it means treatments can target the bacteria specifically without targeting you. Cancer does not work this way. Cancer cells are your own cells. They are you. They came from your own body with your own DNA, doing things your own biology taught them to do. The difference between a cancer cell and a healthy cell is subtle enough that designing a treatment precise enough to destroy one without destroying the other is one of the hardest biological engineering problems in the history of medicine. Traditional chemotherapy essentially solves this problem by making no distinction at all. It attacks all rapidly dividing cells everywhere in the body, which is why chemotherapy causes the side effects it does: hair loss, nausea, immune system damage. Because it is not targeting cancer specifically. It is targeting rapid cell division generally, and hoping the cancer divides faster than everything else. Let's bring up something that most people have never considered about why specific cancers remain so difficult. The problem is not just that cancer cells are hard to target. The problem is that cancer cells evolve. This is the part that makes certain cancers so genuinely terrifying from a scientific standpoint. When you treat a tumor with a drug, some of the cancer cells die, but the ones that survive are by definition the ones with some degree of resistance to that drug. Those survivors then multiply. Now you have a tumor made up of drug-resistant cells. You apply a second drug. The resistant survivors multiply again. This is evolution happening in real time inside a single patient over weeks and months. Some advanced cancers mutate so rapidly that by the time researchers have developed a drug targeting one version of the tumor, that specific version has already evolved into something different. You are trying to hit a target that is actively running away from you and adapting to every weapon you use. Let's bring up the part that should make you angry. Not angry at researchers who are genuinely doing extraordinary work under difficult conditions. Angry at the structural incentives surrounding cancer research and treatment. The modern pharmaceutical industry operates on a profit motive. This is not a conspiracy theory. It is simply how the industry works, and understanding it explains certain patterns that would otherwise be deeply confusing. Developing a drug that significantly extends the life of a cancer patient for an additional 8 months is an enormously profitable product. Developing a drug that cures the cancer entirely and requires only one treatment course is less profitable than a drug that must be taken indefinitely. This does not mean pharmaceutical companies are evil. It means they are rational economic actors responding to the incentives the system creates. But those incentives are not perfectly aligned to find cures. They are aligned to find profitable treatments. These are sometimes the same thing. They are sometimes not. Here is the specific detail that illuminates the problem most clearly. An internal McKinsey report prepared for pharmaceutical industry clients in 2014 explicitly modeled the revenue difference between a cure and a chronic treatment for certain conditions. A cure generates revenue once. A chronic treatment generates revenue for the lifetime of the patient. The report noted this as a business challenge, not an ethical failure, a business challenge. The document exists. It was reported on. The logic it describes is real. You are living in a medical research environment shaped partly by the answer to the question of which outcome is more profitable. And in a significant number of cases, the more profitable outcome is not the cure. Let's bring up what is genuinely exciting in cancer research right now, because this is not entirely a dark story. Immunotherapy is the most significant development in cancer treatment in the last 30 years. The basic idea is elegant and remarkable. Instead of trying to build a drug precise enough to target cancer cells, your immune system is already theoretically capable of recognizing and destroying abnormal cells, including cancer cells. The question is why it sometimes fails to do this. Researchers discovered that cancer cells have mechanisms to essentially hide from or disable the immune system. Immunotherapy drugs block those hiding mechanisms and allow the immune system to do what it was already designed to do. The results in some cancers have been extraordinary. Patients with advanced melanoma that was uniformly fatal in previous decades are now achieving complete remission. Not life extension. Remission. The disease is disappearing. This is real and it is happening. Let's also bring up mRNA technology, which most people only heard about in the context of COVID vaccines, but which has been under development as a cancer treatment approach for over a decade before the pandemic made it famous. mRNA cancer vaccines do not prevent cancer the way traditional vaccines prevent infectious disease. They instruct your immune system to recognize the specific mutations present in your specific tumor. The approach is personalized to an individual patient's particular cancer at the genetic level. Early clinical trials have produced results that researchers are describing with the kind of cautious excitement that scientists very rarely allow themselves to express publicly. The technology exists. The research is happening. The question is how quickly it can be scaled, developed, and made accessible. And here is the uncomfortable thing sitting inside all of that genuine scientific excitement. Even when a treatment works, the question of who can access it is a separate and deeply unequal problem. The most advanced cancer treatments currently available can cost upward of $400,000 per patient per year in the United States. A personalized mRNA cancer treatment, if it reaches the market, will not be cheap. The scientific problem of understanding cancer and the economic problem of making that understanding available to everyone who needs it are two completely separate problems. We could theoretically solve the first and completely fail to solve the second. History suggests this is not a hypothetical concern. Why don't we have a cure for cancer yet? Because cancer is 200 different diseases, not one. Because cancer cells are our own cells, making them almost impossible to target without collateral damage. Because cancer evolves in real time, adapting to every treatment we develop. Because the economic incentives surrounding pharmaceutical research do not perfectly align to find cures. And because the distance between a scientific breakthrough and an accessible treatment is longer and more complicated than the headlines about that breakthrough ever acknowledge. The researchers working on this are not failing. The science is not stalled. Real breakthroughs are happening right now that will change what is possible within our lifetimes. The question is whether the systems surrounding that science will allow those breakthroughs to reach the people who need them. That is not a scientific question. That is a political one. Before I go, I want to know something from you specifically. If you or someone you love has been affected by cancer, I want you to tell me in the comments what you wish more people understood about it. Not statistics, not policy arguments. What you actually wish people knew. I will read every single one.